This is section 11.2, arithmetic sequences. This is a specific type of sequence that changes by adding or subtracting a number to get to the next term. Here is your general form for an arithmetic sequence. I don't know how visible that is. So this would be the first term. This is what it's changing by, common difference. There's another formula. There's also this one, which is probably not on your paper. You should write down. D is your common difference. C, you find C by doing this little piece right here. If you simplify the formula on the left, you get the one that's on the right here. They're the same thing, just so you know. And the nth term of the arithmetic sequence. Well, I tell you it's arithmetic, so somebody's got to be adding or subtracting to get the next term, which it is subtracting 5, and that is your D. So our first term is 9. Our D is -5. So if I plug my pieces in, oopsies. If I simplify this, I get 14 minus 5n. If I use the other formula, my D is -5. C, I take 9 minus -5. Here I get my 14. I get a sub n equals -5n plus 14. They're the same formula. Just you approach it two different ways. Regardless, it needs to be simplified anyways. So make sure you can do both, I guess. They tell you this is an arithmetic sequence, so we just have to continue the pattern. The first 6 terms, well, we have 14 and 8 that's already listed. They're going down by 6. So then we have 2, -4, -10, -16. We want to find the 200th term. If you want to write out 200 of those numbers, by all means, go ahead. I'm just going to write a formula. So my first term is 14. D is -6 because we're going down. If I want to do my C, the one formula, 14 minus -6 is 20. And here's the formula then. If I want the 200th term, stick 200 in, and we see that it is -1180. The 11th term is 63. The 15th term is 87. And we want to find the 100th term. Well, we're going to use this information. So to get to the 15th term, we would be at the 11th term and then add how many more spots? So 11, 12, 13, 14, 15. 4 more spots. 4 times whatever our D is. So I'm going to plug those in. Move 63 over, divide by 4. 6 is what D is. And then I can write my formula. Oh wait, no. I don't have to do that. I don't have to write my formula. We're going to do kind of the same thing. So choose either the 11th or the 15th term. I'll choose the 11th. So to get to the 800th term, if I start at the 11th, I'm going to add D times 789. Right, there's 789 spots between 11 and 800. So I get 63 plus 6 times 7, 89. The 800th term, 4,797. On the back is the partial sums for arithmetic sequences. There's actual formulas. This is what it's written out long-wise. And then there's these 2 formulas. They both mean the same thing, just depending on what type of information is given, depends on which formula you might want to use. So if we want to find the sum of the first 40 terms of an arithmetic sequence, which I didn't list for you, Isn't that funny? Okay, here it is. 3, 10, 17, 24, dot, dot, dot. It's funny that that's not on there. Okay, so we're going to write a formula. Our first term is 3. Our d is 7. So if I use the other formula this time, I get 3 plus n minus 1 times 7. I would distribute that, and we get 7n minus 4 is our formula. We want to find the first 40 terms. Well, looking up at these two, why don't we just do the first one? Why not? First 40 terms. So 40 is the n. A is the first term, which is 3. 40 minus 1 times 7. Oh, bracket. And this should come out to 200 and, nope, that's not the right number. 5,580. I'm going to check on that just to make sure. But now I don't remember what I wrote down. 40 halves, which is 20. So 20 times 6 minus 39 times 7. I think that's what it was. Was it plus? Maybe it was plus. Was it plus? It was plus. Okay. There we go. Plus. Ah, yes. 5,580. The other option to do this, I'll do it in green, is to find what the 40th term is. So if we plug in 40 here, we see that it's 276. And then using the other formula, it's 40, parentheses, the first term, which is 3, plus the last term, which is 276, divided by 2. And we get 5,580 as well. So either way, it works. We want to find the first, the sum of the first 40 odd numbers. So we have 40 numbers. This would be where the second formula is actually useful. The first odd number is a 1. The 40th odd number would be 79 divided by 2. This comes out to be 1,600. An amphitheater is 40 rows of seats with 30 seats in the first, 32 in the second, 34 in the third, and so on. Find the total number of seats. Well, it's going up by 2s, right? So our first term is 30. Our d is 2. And we have 40 rows. So n is 40. We can use that first formula. So 2 times 30 plus 40 minus 1 times 2. Just to be sure. So we have 20 parentheses 60. 2 times 30, 60 plus 39 times 2. 39 times 2. 2760, correct. And the last one, find the number of terms in a partial sum. How many terms of the sequence must we get to get 624? Well, that's our sum. That's going to equal sum n, we don't know what. So we're using the first summation formula. 3 is our first term. N minus 1 here. And then they're going up by 2, so our d is 2. So we're going to distribute all that. Actually, I'm going to get rid of this 2 as well. So 1248 equals n. And then at our brackets, 6 plus 2n minus 2. So this looks like a quadratic. 2n squared. 6 minus 2 is 4, times n is 4n. Bring 1248 over. I'm going to reduce it by 2's to make it easier. Double bubble. So n could be either negative 26 or n could be 24. But if we are talking about the number of terms, you can't have a negative number of terms. So this gets rejected. 24 is our answer. And that is the end.